Hello friends, now we see the problem 2 sub question 3, which is also based on higher order derivative of chapter differentiation. The problem 3 is x equal to square root of a raised sine inverse t and y equal to square root of a raised cos inverse t. And for this question, we have to find d2y by dx square, that is second order derivative. Now let's see the solution. First we start from x is equal to square root of a raised sine inverse t. Let us this denote as a equation number 1. Then we write second function that y is equal to square root of a raised cos inverse t. Let us this denote as a equation number 2. Now multiplying equation 1 and 2, we get x into y is equal to square root of a raised sine inverse t into square root of a raised cos inverse t. Therefore, x into y is equal to, by using indices rule as well as multiplication rule for square root, above function can be written as a raised sine inverse of t plus cos inverse of t. Since square root of a into square root of b gives us square root of a into b, and secondly here we apply one more rule which is a base on trigonometric function, is that sine inverse of t plus cos inverse of t is equal to pi by 2. So the next step will be x into y is equal to square root of, now a raised sine inverse t plus cos inverse t, so that gives us answer pi by 2. So we have square root of a raised pi by 2. Now differentiating this function with respect to x, we get now on LHS the derivative of x into y, that we can find by using product rule of derivative. So by using that rule we can write it as x as it is into d by dx of y plus y as it is into d by dx of x is equal to d by dx of square root of a raised pi by 2. The next step will be x into derivative of y is dy by dx plus y into derivative of x is 1 is equal to derivative of root of a raised pi by 2, so which is a constant term, and hence its derivative is 0. So the next step will be x into dy by dx is equal to, now this y into 1 we get y, and then plus y if we shift on right hand side, so we get minus y. So the next step will be dy by dx is equal to minus y upon x. So this is called first order derivative. Let this denote as a equation number 3. Now to find second order derivative differentiating this above function with respect to x, we get the derivative of dy by dx is d2y by dx square is equal to, and on right hand side we apply quotient rule, that is u upon v rule of derivative. So here first of all we write minus sign as it is, the numerator y that we consider as a u and denominator x consider as a v. So by using quotient rule of derivative we have x we write as it is into d by dx of y, and then minus we write y as it is into d by dx of x, the whole thing divided by x bracket square, and finally square bracket complete. Therefore the next step will be d2y by dx square is equal to minus in bracket we write x as it is, then derivative of y is dy upon dx, then minus we write y as it is into derivative of x is 1 and whole thing divided by x square. Therefore the d2y by dx square is equal to, now minus in bracket x into, for dy by dx from equation 3 we substitute minus y upon x, and then minus y into 1 gives us y upon x square. The next step will be d2y upon dx square is equal to, we write minus as it is, then inside the bracket we cancel x from numerator denominator, so we left with minus y and again minus y upon x square. So d2y by dx square is equal to minus in bracket, now minus y gives minus 2y upon x square, and finally d2y by dx square is equal to minus minus become plus, so we have 2y upon x square. So this is required second order derivative. So therefore this is a required solution for the given problem. Thank you.